Okay, let me have a look. Not yet. Oh, there it is. Which attachment do you want me to start with? Can you tell?
It doesn't matter.
Well, let's go left to right. So we're not going to do CPM tonight at all, right?
Yeah.
All right.
Give me like a minute. I need to go get a pencil real quick.
Okay.
Okay.
All right. First of all, tell me if this is your standard. That look familiar at all?
Yeah.
Is that exactly what you use? Because there's various standards depending on which school district you're in.
No, that's the one we use.
That's exactly with the B outside the parentheses?
Mm-hmm.
Okay. So, in this case, what's the amplitude?
-1.
It's 1. The amplitude is actually the absolute value. Okay, so the amplitude is 1. There is a negative sign there, which means what?
It switches.
Reflects over which axis?
The X.
Okay, good. What's B? Or actually, what's the period?
2 pi.
Yeah, because it's 2 pi over B, and B is 1. So that's 2 pi. And what's the horizontal shift? Oh, I love it! Finally a trig course that calls it a horizontal shift instead of a phase shift. I've been wanting them to do that for years. What is the horizontal shift?
Pi over 2.
Which way?
To the right.
And finally, what's the vertical shift?
Up 1.
Yeah. Finally, I am not kidding you. I've been tutoring trig for 8 years, and this is the first time that I've ever seen anybody call it by the same things that you deal with when you're dealing with transformations of polynomials. In other words, calling it a horizontal shift and a vertical shift, and instead of amplitude, they should have called it a vertical stretch, because that's what amplitude is vertical stretch. Okay, let's look at this curve. Little different, tangents. First of all, what's the natural period of cosine?
Pi over B.
2 pi. The natural period of sine or cosine is 2 pi. In other words, if I said this curve right here, that's y equals sine x, that period is 2 pi. Okay?
Yeah.
What's the natural period of tangent?
Pi over 2. Or pi over B.
Just pi. Just pi. They're different that way. If I draw a tangent graph, looks like that, and every pi there's an asymptote, and it just repeats. starts at minus pi over 2. That's pi over 2. That's 3 pi over 2. So the period of the tangent curve, normally, if you're just talking about tangent, is pi, not 2 pi. It's different from the sine and the cosine curve. Okay? And what that means is when you go to figure out the period based on b, it's no longer b equals 2 pi over the period. It's the period, equals pi over b. So what's the amplitude of this?
Pi over 2.
Am-
1.
Amplitude is 1. Period is pi over 2. Horizontal shift?
0.
Vertical shift?
0.
What's the, oh, okay, so they use H and K instead of C and D. I've seen that lots of times also. It's amazing how many different standard formats there are for the sinusoid function. I mean, if you include all the variation of letters, I could name you 6 different standard formats. But they all basically are the same. In other words, the A is always in front of the sine or cosine. Doesn't have to be sine, it can be cosine. The B is usually in front of the parentheses, but sometimes you'll find the B inside the parentheses next to the X. And if that's what you find, you have to factor that B out. And it makes a difference because sometimes H is the horizontal shift and sometimes it's not, depending on where the B is. The K is always the vertical shift. Number 6. They want the X and the Y-intercepts. Let's start with the easiest one. What's the Y-intercept?
-6.
Which is when X is equal to 0. That's what you want to remember, is when X is equal to 0, that's the Y-intercept. What's the X-intercept?
When
Y is what?
equal to 0.
Yeah, that's the key. X-intercepts are when Y equals 0. Y-intercepts are when X equals 0. Well, the Y-intercept's much easier to solve for because when you set X equal to 0, it only leaves -6. But when you set Y equal to 0, now it becomes a factoring problem. Hopefully they didn't give us one that can't be factored. This is one of the more difficult ones to factor. And the reason is that there are 3 different factors of the number 6, 2 different, and there's 2 different factors of that 6. So there's lots of possible combinations. Which one are we going to start with?
6xx.
Now, you know what I tell everybody? Start with the 2 closest ones. 3 and 2 are much closer than 6 and 1. And just from my experience, when you have problems like this, the answers are almost always the 2 closest factors. What are my signs? Both signs. Gotta be opposite, don't they?
Yeah.
I cannot produce a -6 if both signs are the same. So they got to be opposite. But in this case, Plus minus is not exactly the same as minus plus. So I have to allow for both of them. Now, I'm looking for factors of 6. And that's it. I cannot say they have to subtract to 5. I cannot say they have to add to 5. I can't say anything. I just know that they have to multiply to 6. So pick 2 factors of 6 and we'll start trying them randomly.
2, 3.
Okay, I'm going to start with that one. Now, the goal here is to produce the middle term. What middle term does this produce? What's the top smiley face? Plus 4x. In other words, that smiley face means the product of those two. The bottom smiley face means the product of those three, or of those two. That's minus 9x. Add those together, you get minus 5x. Well, that's not our middle term, but it's awfully close. What do I have to do to my factors?
Change them.
Well, I got to move this 2 down to here, and I got to move that 3 down to there. And that'll give me the exact result that I want. Notice, now, when I do the middle terms, I get a minus 4x, I get a plus 9x, and add those to get plus 5x. That's the correct solution. I'm done. Now, what else did they ask here? Find the x and y-intercepts. So we're not quite done. What's the x-intercept? Or intercepts?
Negative 3/2 and 2/3.
Nicholas, you got good math skills. What are you getting in your grade right now?
Like my total, you know?
I don't know. What kind of grade are you getting at the moment?
I'm a high C.
Just curious. I see very few students that got the kind of math skills that you have. You should take advantage of them. I don't know what your goals are, whether they're, to go to college or be an engineer or something, but you got good math skills. All right, let's see. X squared minus 2x. I'm writing these just because copy is blurry enough that it makes it tough to work on the copy. Simplify the following rational expressions. Include all work and the excluded values for A and C. Well, I'm not. Okay, I know what they mean by that. So what am I going to do here?
Factor the bottom of both sides.
Okay, what does that give you?
X minus 3x plus 1. And x minus 3x minus 2.
Now what?
Well, you multiply 4x by
We need a common denominator, do we not?
yeah.
What's the common denominator going to be? I find that that's always the easiest way to proceed, is write your common denominator down. What is it?
3.
Now, the common denominator is usually the product of those two denominators, but it's not always. We don't have to square x minus 3. the property that a common denominator has to have is it has to be evenly divisible by that, and it has to be evenly divisible by that. Notice that the denominator that I have written is evenly divisible by both denominators. All right, you with me?
Yeah.
Now tell me what that should be.
4x.
Give it to me in factored form.
4x minus 8. Or,
That's the reason I like writing it like this. Notice that I did not multiply the bottoms together. I do not want to multiply the bottoms together. The key in solving this problem is to make sure you do not change that fraction. And when I write it like this, I can tell, wow, that x minus 2 cancels with that x minus 2, and I'm back to exactly what I started with. So I would always recommend to everybody that you write it this way. In other words, you do not multiply the bottoms together. You leave them in factored form. Now, what's this top right numerator?
3x plus 3.
All right, well, let's write it like that just so we know what we're doing. In other words, by writing it like this, again, I can ensure that that is identical to that without too much difficulty, because that x plus 1 cancels with that x plus 1, and I got the same thing. So in all math, it's always worth checking your problem as you go. You don't want to get to the end of the problem and then try to figure out checking each step. It's just too hard. But if you check it as you go, you'll pick up errors that you might make. Now, common denominator is still this. And as all I'm going to do is operate on the numerator. What's the numerator give me?
4x squared. Minus 8x.
Minus, okay.
Minus 3x plus 3.
Is it plus 3?
Or minus 3.
You see why it's got to be minus 3? I really need to put that whole thing in parentheses. I am subtracting that fraction. And that fraction, if I don't put it in parentheses, it's really easy to get the sign wrong on that term. And that's all you have to do is make one mistake and you're going to get this wrong. You cannot make a single mistake on a problem like this. Now, what's the numerator simplified to?
4x squared minus 11x minus 3.
Now, even though I've never seen it to be the case, I continually hope that eventually I'm going to find it to be the case, where it's possible that I could factor the numerator, and if I come up with a factor that's either x minus 3, x plus 1, or x minus 2, then I can simplify it tremendously. If I cannot come up with one of those factors, then it's already simplified. So, I think I can come up with one. Or at least I can come up with, I can factor the numerator, which is something. It's got to be minus 3 plus 1. That gives me that numerator, right?
Mm-hmm.
And I do have a minus 3 in the bottom. So I can factor it. So I finally found one of the problems they give that allows you to simplify it by factoring. I'm telling you that for 8 years, I'll bet I have not found more than one of those. It's like a 4-leaf clover. This is my final answer. Because I was able to factor the numerator and come up with a factor that matched one of the factors in the denominator. That was a good problem. I should write that down and save it. Hold on. So, the next problem, let's have a look at it. They get more and more complicated looking. That doesn't mean they're harder. In fact, the more complicated looking they get, the easier they tend to be. In other words, once you come up with the method, I just saw the instructions. The excluded values for A and C. Let's go back a step. Look at the answer I came up with. 4x plus 1 over x plus 1 times x minus 2. What can x not be?
-1, 3, and 2.
Very good. In other words, just because that thing canceled does not eliminate the domain restriction. I still cannot ever have x be equal to 3. Even though if I were to look at this function alone, I would never come up with a domain restriction of x can't be equal to 3. But the fact that the original function had an x minus 3 in the denominator means x can never be equal to 3 no matter how many times you cancel out that factor. I lost my way here. What are we doing? We're doing B, right? Yeah. I forgot to talk about the excluded values the first time we went through that. Wow. Huh. Hold on a second. There we go. All right, let's write this again. Right off the get-go, before we do anything else, what are the excluded values for x?
0 and 1.
Okay. That's never going to change no matter what we do to this function. No matter how we manipulate it, x can still never be equal to 1 and never be equal to 0. Now, operate on the numerator only. Solve that problem right there. How do you handle that? What's the common denominator?
X minus 1.
That numerator is clearly 6. What's this numerator?
3 times x minus 1.
Simplify that. What's the numerator going to be?
Negative 3x plus 9. Or 6 minus 3x minus 3. Or plus 3.
Plus 3. So you end up with 9 minus 3x over x minus 1. So that's our numerator. Let's substitute that for our numerator, since I ran out of space. Now, how do I do this problem right here?
You multiply the top by the reciprocal of the bottom.
Okay. So I end up with 9 minus 3x over x minus 1 times x over 3. That gives me 9x minus 3x squared over 3x minus 3. You see any way of simplifying that?
No.
I don't either. But sometimes when there's numbers like this, it doesn't always jump out at you. So let's factor the greatest common factor out of the top. Let's factor the bottom. Now I see I can do something. What can I do? Cancel those 3's. In other words, simplifying is often just a question of reducing it as much as you can. Leaving this. Now I do not believe I can simplify it anymore. I think that's the final answer. But you for sure would lose at least a point if you gave that answer or this answer without canceling the 3's. And remember that even though this is our final answer, and it looks like the only thing x can't be is 1, we go back to the original, x can't be 1, and it still cannot be 0. No matter what we turned it into, those original domain restrictions still apply. The moment I see C, what kind of problem is it? It's a factoring problem. In other words, when I see a linear term in the numerator and a quadratic down there, and then I see a linear term in that numerator and a quadratic in the denominator, I know it's a factoring problem. They all are. If it wasn't, they wouldn't be giving it to you. So factor the bottom. Just immediately when you see a quadratic, factor it. When you have a problem kind of like this. What's the bottom factor into?
X minus 7, x plus 5.
What's this bottom factor into?
X plus 5, x plus 2.
What's the least common denominator going to be?
X minus 7, x plus 5, x plus 2.
What's the top left numerator going to be? It's got to be so that I don't change. In other words, this has to be the same as this. That's the way you figure it out.
X plus 1 times x plus 2.
The top right numerator.
X plus 6 times x minus 7.
Now, we've got to reduce this. We know it can be reduced. In other words, there's no way this could possibly be the final answer. Because I'm going to be able to, I got an x squared at least in the top left, and I got an x squared at least in the top right. So if nothing else, I'm going to be able to combine those two terms to have a 2x squared in the numerator, which tells me that I've got to multiply these things out and combine them. So the top left, multiply those two. What do you get?
X squared plus 3x plus 2.
Top right. Because there's a plus sign there, I don't need parentheses.
X squared minus x minus 42.
Now, combine everything. In the numerator, what do you get?
2x squared plus 2x minus 40.
We still have this denominator, common denominator, which I definitely do not want to multiply together. I want to leave it factored. Now, at the very minimum, I can take a greatest common factor out of the top. 2. Question is, does that leave a quadratic that can be factored and have a term that will cancel? In other words, it doesn't do me much good to factor that quadratic if I don't end up with something in the denominator that's the same. See why? In other words, it's not going to do, if I ended up with x plus 9 times x minus 10, then I'm not really simplifying it. But what does the numerator factor into?
X minus 5, x plus 4.
I think it's x plus 5 times x minus 4. Remember that the bigger factor has to go with the sign of the middle term.
Mm-hmm.
Now, that cancels with that. So I end up with an answer, and I don't really care if you multiply that 2 out or not. I personally prefer it not to be multiplied. I would prefer my answers to be in factored form, not multiplied out. And that's what I get, although there are some restrictions. What can x not be?
7, negative 2, and negative 5.
Aha. Remembered the negative 5. That's good. What the hell happened, Nicholas? All of a sudden you became a genius at this stuff.
Yeah.
Well, what am I missing?
I actually understand this unit, but my mom thinks I still need tutoring.
Oh, okay. All right.
You're right.
You're right. You do understand this unit. Which is pretty good, because this is not all of that easy. But your mom probably still thinks you need tutoring because you're getting a C. If you want to convince her you don't need tutoring, you need to get your grade up to at least a B.
Yeah, that's what I'm trying to do.
As much as that would work against my interests, I would love to see it. You should be getting a B. You should be getting an A, just based on your math skills.
Yeah, I just had a rough start, so.
Okay. So, how to handle this? What can I do to make things a little bit simplified?
You could factor out a 4, or the 4x plus 12.
Not a 4. If I'm, in other words, deal with this numerator first, and then deal with the bottom second. But the bottom, I can do something with both terms that I've circled. What's the numerator? If I divide top and bottom by 2, what do I get?
2x plus 6.
Hold on.
6
Divide top and bottom by 2. Just that.
1 over 2x plus 6.
Now, take this term on the lower left and divide top and bottom by 2. Maybe we don't want to do that. Hold on a second. Almost always it's worth simplifying these. But it just occurred to me that there's something happening here that we can take advantage of. If I don't simplify that and leave it like that, if I can get a denominator of 2x plus 6 down here, this whole problem is going to be a lot easier. Well, how do I get a denominator of 2x plus 6? I multiply top and bottom by 2. See what I did? I turned this term into 2 over 2x plus 6. The reason I did it is because now we have a common denominator in the top and the bottom. And whenever you have that situation, you can basically cross those out. And the answer is 1 over 6, 4 plus 2. So the problem was simplified not by necessarily simplifying the 2x plus 6, but noticing that I already had a 2x plus 6 up there. I already have one on the lower left. If I can make the lower right a 2x plus 6, the whole problem, the difficulty disappears. Now, let's talk about something that may not be obvious. If I have a over b divided by c over b, I can cancel those out and I'm left with a over c. With me?
Mm-hmm.
If I have a over b divided by a over c, I cannot do that same thing. Notice that in the situation on the left, I cannot cancel the a's out and say I've got b over c. It's the numerators that are the same. If I flip and multiply, I get c over b, not b over c. So you got to be a little careful when you're doing this trick that I did in the last problem, where I had both denominators were 2x plus 6, I could cancel them out. And I'm left with just that over 4 plus 2. Just make sure that whenever you do that, your denominators are the same, not your numerators. Your numerators were the same, you'd have to flip it, and it would be 6 over 1. Do we have another page here?
Yeah.
What was that, the first one on the left?
Mm-hmm.
Okay. All right. We're going to call that the angle. Right? Negative angles are measured clockwise. Positive angles are measured counterclockwise. So that's minus 136 degrees. Now, the question is if we have a unit circle, what are the coordinates of that point? Well, here's the way you figure it out. You draw a triangle, you make that theta. I know the hypotenuse is 1 because it's a unit circle. So give me a trig function that allows me to figure out the x and y coordinates of my x. Just look at this triangle right there. We've got a hypotenuse length. We're trying to figure out the y coordinate, and we're trying to figure out the x coordinate. So give me a trig function that relates, let's start with x. What trig function relates x and 1? So trig is what's giving you difficulty. Okay. I mean, you had every answer within 2 seconds on every other problem. So what trig function relates x, the adjacent side, and 1, the hypotenuse? Cosine. Cosine of theta equals x over 1, right?
Okay.
What's theta?
Sine of...
Hold it. What's theta? If this is 136 degrees, what's theta?
So sine of 130, or yeah, 136.
What's theta? It's an acute angle. Well, give me the positive acute angle that theta is.
44.
Okay. So it's the cosine of 44 equals x. Now, we can see from our diagram that x needs to be negative. So, but the numbers are the same. Put in your calculator cosine of 44. What do you get? It's a number.
0.719.
Now, look at the picture and tell me, should x be negative or positive?
Negative.
That's all you have to do to solve these kind of problems. It's always this reference angle that produces the trig answer. It's not the 136 degrees, it's the angle that is made with the x-axis. That's the one you have to figure out. And then you can see whether it should be positive or negative. The x is clearly negative, the y is negative. So we actually only figured out the x coordinate, negative 0.719. What's the y coordinate? I forgot. What's the y coordinate going to be? Give me a trig function. Whenever you're trying to solve these problems like this, always try to start out your equation with a trig function on the left. In other words, figure out the trig function you want to use, and then start with the trig function of that angle. What trig function relates y to 1? The opposite to the hypotenuse.
Sine of theta.
So sine of 44 degrees equals what?
Y over 1.
equals y. What's the sine of 44 degrees? Give me that number.
0.694.
Should that be positive or negative?
Negative.
Yeah, you can see that the y is a negative measurement. In other words, anything that's going down is negative. If it goes up, it's positive. For the x, if it goes to the right, it's positive. If it goes to the left, it's negative. So this is what they want for an answer. When they want the coordinates of the point P, we need to use the sine and the cosine. It's always sine and cosine. And just in case you're wondering, the hypotenuse in a unit circle is always positive, no matter which quadrant it is in. The unit circle is your first exposure to polar coordinates. And in polar coordinates, the ray is always positive, no matter which way it points. And that's what you're looking at with a unit circle, is a positive ray. But the answer to those problems are always based on the sine and the cosine of the reference angle. So here, the angle is 3 pi over 7. Well, that's slightly less than pi over 2, correct?
Mm-hmm.
So that's 3 pi over 7. That's what that angle is. And I got a unit circle. So they want the coordinates right there. Well, there's an xy coordinate there. And the most important thing you can remember is that the x-coordinate is the cosine of theta. The y-coordinate is the sine of theta, no matter where you're at on the unit circle. That's true. So the x-coordinate is going to be what? You're going to have to get out of your calculator, but give me the expression. Remember, the x-coordinate is cosine of theta, no matter where you're at on the unit circle or which quadrant. And the y-coordinate is sine of theta. So what's the x-coordinate going to be? Cosine of the angle. Cosine of theta. The angle is 3 pi over 7. That's going to be the x-coordinate. Put that in your calculator and make sure you're in radians. What do you get? What kind of calculator do you have, Nicholas?
I'm just using my phone right now because I can't find my other one.
All right. So you probably don't have an easy way to put it in radians?
No, I do.
Oh, okay. Go ahead. What is this?
0.222.
Is that going to be positive or negative?
Positive.
What's the y-coordinate?
Sine of 3 pi over 7.
What number is that? First of all, would you expect it to be closer to 0 or closer to 1? Look at the picture.
Closer to 1.
Okay, what is it?
0.974.
So that's what I'm going to put in there for x and y. Are 0.222 and 0.974. And that's how you do it. No matter where you're at on the unit circle, your coordinates, the x-coordinate is always cosine of theta, the y-coordinate is always sine of theta. And I actually could have done that on the previous problem and it would have been a little quicker. I could have said the x-coordinate is the cosine of minus 136 degrees, And the y-coordinate is going to be the sine of minus 136 degrees. And I could have gotten it immediately out of your calculator based on that. I actually did it the slow way the first time we did it. Not sure why, I just kind of spaced out the fact that the x and y coordinates on the unit circle are always cosine of theta, comma, sine of theta. Now, how do I get the cosine? Yeah, you can get that out of your calculator. What's the cosine of minus 136?
Negative.
Make sure you're back in degrees. In other words, they're jumping back and forth between radians and degrees.
It's a negative 0.719.
And that was the answer we had before, right?
Yeah.
Well, we got it a lot quicker with one keystroke entry. What's the sine of negative 136 degrees?
Negative 0.694.
And that's the same answer we got also. So that's the most important thing you can probably get out of tonight's lesson, is that the x-coordinate is the cosine of theta, the y-coordinate is the sine of theta, always, as long as you're dealing with the unit circle. If you're dealing with a circle that's got a radius of 2, then that's not true. But as long as you're dealing with a circle that's got a radius of 1, this is always true. See what else we have on here that maybe can be done in 5 minutes. Just a second. I certainly don't need that line there. Okay. All right, number 9A is the classic trig problem. We got just enough time to do it. It's where they give you the result of one trig function. Does that say what? 6 over 7? What does that say?
6 over 7.
6 over 7? And they tell you the quadrant that it's in. Based on that information alone, I can tell you all other 5 trig functions. They only ask for one, sine of theta. But the solution always lies in the same method. What's the first thing I got to do? Draw a right triangle and label theta. Now, dimension that triangle for me as much as you can.
Okay,
What's the adjacent side got to be?
6.
What's the rest of it?
The hypotenuse 7.
What's this opposite side?
X.
Well, you can solve for it. This is a right triangle. You can solve a right triangle. That's the key to these problems, is solving that third side. It's the square root of the hypotenuse squared minus the other short side squared. 49 minus 36 is the square root of 13. So that's that side. Okay? Now, once we got this triangle fully dimensioned, I can give you any trig function. I know it's in the first quadrant, so they're all positive. Tell me what the sine of theta is.
It's root 13 over 6.
Over 7.
Oh, yeah, sorry.
Opposite over hypotenuse. Now, notice the most important thing in this problem. We never solved for theta. That would have been another way to do it. In other words, if I started out with cosine of theta equals 6/7, I can take the inverse cosine of 6/7 and solve for theta. Then I can take the sine of theta. So that would be another way to do it, but that's a bad way to do it. this way of doing it, I can get all 6 trig functions just by reading that triangle, and at no point do I know what theta is. It's a thing of beauty. And so whenever you have this problem, and I mean it, this is a classic, if I was giving a trig test and I was only going to ask one problem, might be this kind of problem. It doesn't have to be A and B are basically the same. Notice they give you the results of one trig function and they tell you what quadrant it's in. Now the fact that they tell you it's quadrant 2 tells you that the tangent of theta is going to be negative. So whatever you come up with for the ratio, you're going to have to stick a negative sign in front of it. But these problems are all the same. You begin them by drawing a triangle and labeling theta. And dimensioning 2 sides of that triangle, use the Pythagorean theorem to dimension the 3rd side. Once you have all 3 sides dimensioned, you can give all 6 trig functions of theta. Then put the correct plus or minus sign on it based on what quadrant it's in. All right, Nicholas, I'm going to let you go.
Okay.
I will talk to you next time.
Okay. Bye.